वेलकम टू माय चैनल एंड थैंक यू फॉर वाचिंग द वीडियोस। इस वीडियो में हम चारपिट मेथड पर बेस्ड एग्जांपल्स करेंगे। इम्पॉर्टेंट टॉपिक है, कई बार एग्जामिनेशन में क्वेश्चन आया है इस पर बेस्ड। सो पास्ट ईयर एग्जामिनेशन पेपर्स के कुछ क्वेश्चंस करते हैं। 2021 का एग्जाम्पल है P इज इक्वल टू Z plus QY square and we have to find out complete integral. Find the complete integral of this equation. So fxy zpq is equal to Z plus QY whole square minus P is equal to 0. So this is equation 1. Now we know Charpit'S auxiliary equations are dP upon fx plus pfz is equal to dq upon fy plus qfz is equal to dz upon minus pfp minus qfq is equal to dx upon minus fp is equal to dy upon minus fq. So we find partial derivatives, that is fx, fy, fz, fp and fq. So these are the values we have obtained. Now we put in auxiliary equation dP upon fx plus p fz. So fx is 0 plus p into fz is 2z plus qy. This cancels out later on. So this is cancellation mark is equal to dq upon 4 qz plus qy, because this is fy plus qfz. So we multiply this by q and add, then this becomes 4qz plus qy is equal to dz upon p fp. Fp is minus 1 with minus sign. This is minus pfp. So this becomes plus p minus qfq. So q into fq, this with minus sign. So we got this. Now dx upon minus fp. So plus 1 and is equal to dy upon minus fq. So minus 2yz plus qy. So we take dp upon whatever is equal to dy upon this, these two terms for integration, this dy and dp. So denominators cancels out, only in this is dp upon p and in this it is dp upon minus y. We integrate them, log p is equal to minus log y plus log c. So p is equal to c upon y. Now we put this value of p in the given equation, given in the question. So we have this and this is the value of p. So from here we find out value of q. So qy is this, then we got value of q is this. Now we put these values in, dz is equal to p dx plus q dy. So this is p and this is q and this is dy. We cross multiply, so y here, this cancels out, this cancels out, and we get y here. So y dz is equal to c dx plus under root c upon y minus z dy. So we got this expression. We come here, this expression, and now we take z dy term on this side here, and then we find out value of this yz, integrate it. So when we integrate it, we get yz is equal to cx plus, because this whole term y dz plus z dy integration, when we do, it comes yz is equal to c dx plus under root c y to the power half into 2. This question came in 1994. Here we have to find out the complete integral, and expression is this. This is fxyz pq Charpit'S. These are the auxiliary equations we have written. We find out the partial derivatives, put these values in these equations, and then we have to find out two fractions which we have to integrate. So we have cancelled out this with this, so we get these two, dp and dq, because log p and log q will be the integration simply. So we do this and let's see. So integration gives this, we get p is equal to qc, because these two terms we took. Now this was the given equation in the question. In this we put p is equal to qc and then solve it. We get q and dz is equal to p dx plus q dy. Just simplify it, then integrate it, and this is the simplification and integration, and we get the answer. Here we see that we have taken substitution when we do integration, and this is this much, 1 minus z square is equal to t minus 2z dz is equal to dt. And I think you know the integration process, just do it. This question came in 4 years like 1991, 2003, 7 and 8. Find a complete singular integrals of this. So fxyz pq is this expression, and then we find partial derivatives. These are the partial derivatives with respect to x, y, z, p and q, and then we put them in auxiliary equation, and then Charpit'S auxiliary equations are dp upon fx plus pfz is equal to dq upon fy plus qfz is equal to dz upon minus p fp minus qfq is equal to dx upon minus fp is equal to dy upon minus fq. So we have already calculated, we substitute the values. Dp upon 2z minus 2xp minus 2qy, and this will be p into fz2x. It will cancel out, is equal to dq upon minus 2qx and plus q into 2x. So this also cancels out, 0, is equal to dz upon minus p minus x square plus q minus q minus 2xy plus p is equal to dx upon x square minus q is equal to dy upon minus 2xy minus p is equal to dz upon, this we write again, px square minus 2pq plus 2xyq and minus pq. This minus q has been already included here. So now this happens, it was minus pq, so 1 we have already added, it becomes minus 2pq, and this is cancelled. Now we have to take two terms, and we have to take the easiest one. We take dq upon 0, so we integrate it. It gives q is equal to, it gives dq is equal to 0, so q is equal to a, and any term we can take with this, so q is equal to a. Now we want to find out p, so we use the given function 2xz minus px square minus 2qxy plus pq is equal to 0. So we substitute q is equal to a. 2xz minus px square minus 2axy plus ap is equal to 0. So p minus x square minus a, this is plus a, is equal to 2axy and minus 2xz. So p is equal to 2axy minus 2xz upon a minus x square. If we want to write x square minus a convenient form, we can write 2xz minus 2axy upon x square minus a. Now we put this into dz. dz is equal to p dx plus q dy. So p is 2xz minus 2axy upon x square minus a into dx plus q is a dy. We take common from here 2x, so z minus ay dx upon x square minus a plus a dy is equal to dz. Now we separate the terms, so separable variable, z terms together, x term together, so we can say we divide it by z minus ay. dz upon z minus ay is equal to 2x dx upon x square minus a plus a dy upon z minus ay. Now we club these two terms and we get dz minus a dy upon z minus ay is equal to 2x dx upon x square minus a. Now we can integrate it. If we integrate, we will get the answer. The term was dz minus a dy upon z minus ay is equal to 2x dx upon x square minus a. Integrating, we get log z minus ay is equal to log x square minus a plus log b. a, b are arbitrary constants, so this gives z minus ay is equal to x square minus a into b. So z is equal to ay plus x square minus a into b. This is complete integral and a and b are arbitrary constants. Now we have to find out singular integral. So for singular integral, we will differentiate z with respect to a and b. First with respect to a, 0 is equal to y minus b. Then with respect to b, 0 is equal to x square minus a. So from here we get y is equal to b, from here x square is equal. So we got the values of a and b. We put it in z. Z is equal to a x square into y plus x square minus x square into b. So this is 0, it is x square into y. So this is singular integral. And this is the required answer. Next example is this example is of 1999 CSC Ias. Complete integral find out करना है of p square plus q square minus 2px minus 2qy plus 2xy is equal to 0. So ये हो गया fxyz pq is equal to 0. Now we find out partial derivatives. Fx is minus 2p plus 2y. Other variables we take as constant. So with respect to y will be minus 2q and plus 2x. Fz is not there, so fz is 0. Fp is 2p from here, from p square, and minus 2x from here. Then fq 2q, which is from q square, and minus 2y. Now we write Charpit'S auxiliary equations, and these are dp upon fx plus pfz, dq upon fy plus qfz, dz is minus p fp minus q fq is equal to dx upon minus fp is equal to dy upon minus fq. Now we put values in these auxiliary equations. So dp upon fx is minus 2p plus 2y and plus p into fz is 0 is equal to dq upon fq is fy is minus 2q plus 2x plus q into 0 is equal to dz upon minus p into fp 2p minus 2x and minus q fq 2q minus 2y is equal to dx upon minus fp minus 2p minus plus 2x and is equal to dy upon minus fq minus 2q plus 2y. 2 may be cancelled from each term. And it can be written, we see that dp upon minus p plus y, we see we cannot integrate them directly because they are combination of two variables, so we have to separate them. We have to make some calculation like this that they can be integrated, so we add a few terms and make denominator 0, or we can cancel out them. So we see if we add dp and dq and dx and dy, they can be cancelled out because x plus y and minus p minus q. So dp plus dq upon minus p plus y minus q plus x is equal to dx plus dy upon minus p plus x plus q minus q plus y. So these are cancelled denominators, so only numerators are there. Dp plus dq is equal to dx plus dy. Now we can integrate them. So an integration gives p plus q is equal to x plus y and some constant a. A is arbitrary constant, so we can write them in p minus x plus q minus y is equal to a. From here we can write down value of q or p. So q minus y will be a minus p minus x. Now we put this value of q minus y in the given function. So first we write given function in the form which can be in the form of p minus x and q minus y. So fxyz pq is p square plus q square minus 2px minus 2qy plus 2xy is equal to 0. So we can see we add terms into it because 2xy 2qy, so we can make it perfect square. So p square plus q square plus x square plus y square, and here we can take minus 2px minus 2qy, and on this side also we add x square plus y square because here we have added, and minus 2xy. So this becomes p minus x whole square plus q minus y whole square is equal to x minus y whole square. Now in this we write value of q minus 1. So p minus x whole square, q minus 1 is a minus, q minus y is a minus p minus x whole square is equal to x minus y whole square. Now from here we write p minus x whole square is equal to x minus y whole square minus, or we write this is minus and plus a square plus p minus x whole square minus 2a p minus x is equal to 0. So what happens, we write it in quadratic form and it becomes 2p minus x whole square minus 2ap minus x plus a square minus x minus y whole square is equal to 0. So now this is quadratic in p minus x, this is constant term. So we can write roots from here, and which is p minus x is equal to minus b, this is b, so 2a minus 2a and minus plus minus under root b square minus 4ac, so 4a square minus 4 into 2 into a square minus x minus y whole square upon 2a, so that is 4, 2 into 2, 4. So we can take 4 common from here, and this becomes p minus x is equal to 1 by 2, means a by 2 plus minus, when we take 4 common, so under root 2, so this is 1 upon 2 under root a square minus 2a square minus x minus y whole square. Now we got p because we take x on that side, so we can find out q also. Q is basically q minus y is a minus p minus x. So q is equal to y plus a minus p plus x. So we put value of p from here. This is y plus a plus x, and this is plus x plus a by 2 plus minus, so minus before everything because it is minus p, a by 2 plus minus under root a square minus 2a square minus x minus y whole square. So this comes y plus a, this x and this x will cancel out, minus a by 2, and this will change sign, minus plus under root a square minus 2a square minus x minus y whole square. So this is the value of q, and this we can write a by 2. Now we put these values in dz. dz is equal to p dx plus q dy. So we write p dx p is equal to x. So x plus x dx plus a by 2 plus minus 1 by 2 under root a square minus 2 x minus y. We make it plus. So what do? We have this 2a square and this is a square. So we write it minus a square and then this minus minus plus 2 x minus y square dx plus y dy. Q is this. Similarly here we simplify this, so this becomes plus a by 2 minus plus this becomes 2 x minus y whole square minus a square dy. So this 1 by 2 we had taken inside, so here also 1 by 2 1 by 2. Now we club the terms x dx plus y dy, a by 2 dx plus a by 2 dy, and this we take common, which is 2x minus y whole square minus a square, and outside 1 by 2 dx dy. Sign is reverse, so let's write it. So this is x dx plus y dy plus a by 2 dx plus a by 2 dy, and now we take common, so this is 1 by 2 under root 2x minus y whole square minus a square dx minus dy. Now before integration we use the formula. What will we do? We take root 2 and root 2 inside, so this will be this and this will be this, so this will cancel out, and now the function is this. ये क्या फॉर्म हो गई? x square minus a square. So integral x square minus a square dx का फॉर्मूला है x by 2 x square minus a square to the power half minus a square by 2 log x plus x square minus a square to the power half. फॉर्मूला प्लीज रिमेंबर करेंगे तो इजी रहेगा. Now what happens? We use this. So as I said, we can integrate it. We can write z. So integrating z is equal to x dx plus y dy is x square plus y square by 2. This happens 1 by 2 2x dx plus 2y dy, and this cancels out, so we get this plus a by 2 x plus y. Now we use this formula plus 1 by root 2, and here x is x minus y, so x minus y whole square minus a square by 2 under root, because this half, so we can write like this also, half minus a square by 4, because a square by 2 and by 2 is 4 log x is x minus y plus x square minus a square to the power half, that is x minus y square minus a square by 2 to the power half. So this is the complete integral and ये required solution है. नेक्स्ट क्वेश्चन 2017 में एग्जामिनेशन में आया था. यहाँ भी कंप्लीट इंटीग्रल फाइंड करना है एंड फंक्शन है 2pq प्लस yp प्लस qx प्लस एक्स स्क्वायर प्लस वाई स्क्वायर इज इक्वल टू 0. सो पार्शियल डेरिवेटिव फाइंड आउट करते हैं. fx is 2q plus 2x, fy is 2p plus 2y, fz is then fp is 2q plus 2y and fq is 2p plus 2x. Charpit'S auxiliary equations लिख लेते हैं. So this is dp upon fx plus p fz is equal to dq fy plus qfz is equal to dz upon minus pfp minus qfq is equal to dx upon minus fp is equal to dy upon minus fq. So values substitute करते हैं. dp upon fx is 2q plus 2x plus p into 0 is equal to dq upon fy is 2p plus y plus 0 is equal to dz upon minus p. So dz upon minus p into fp, that is 2q plus y minus q fq, 2 into p plus x is equal to dx upon fp minus fp. So this is 2q plus y with minus sign is equal to dy upon minus 2, and it comes. Now we see that these are not separate, we cannot integrate because combination of them are there, and that too q plus x with dp and p plus y with q. So we have to make some arrangement so these can be simplified. Either denominator can be 0 or denominator can be exact, numerator can be exact differentiation of denominator, or denominator of two fractions may be cancelled out. So many combinations may be there. So we add dp plus dq and dx and dy. So we added and we see that denominator has been cancelled out. So it becomes denominator 0 means numerator 0. So this is numerator 0 and these are equal to each of these above fractions. So if this is not 0, if it cancels with another fractions denominator, that also we can check, but here denominator is 0, so no worry, and we can integrate it directly. Numerator, which is equal to p plus q plus x plus y, is equal to some constant. This is arbitrary constant. Now we can write it p plus x plus q plus y is equal to a. Now from here we can write p plus q in terms of q. So p plus x is equal to a minus q plus y. we write it in the function which is given to us, and function is f is 2pq plus yp plus qx plus x square plus y square. So we make it in the form of p plus x and q plus y. So we rewrite it and it gives 2pq plus 2qx plus 2yp. So what we do, we add 2xy and subtract 2xy. 2xy minus 2xy plus x square plus y square. So we take a common from here. Q, it gives p plus x. From here 2y and it gives p plus x. And it is x minus y whole square. So from here we take p plus x and 2 common, so q plus y plus x minus y whole square, and function is equal to 0, so this is 0. So it gives p plus x q plus y is equal to minus, or we can say plus, x minus y whole square by 2 is equal to 0. So as we got addition of two roots here and product of, this is product and this is addition, so we can find out subtraction of this. So we can write down p plus x minus q plus y is equal to under root a plus b square minus 4ac. So p plus x plus q plus y square minus 4 p plus x into q plus y. If we know a and b, two roots of a quadratic, so we can write a minus b as a plus b square minus 4ab under root of that. So this we can have p plus x plus q plus y is a from here, so a square minus, this is equal to, product is minus x minus y whole square by 2. So this becomes, so minus minus plus x minus y square upon 2 into 4. So this becomes 2 is equal to under root a square plus 2x minus y whole square. This is p plus x minus q plus y. Now we add, say this is a, capital A, this is capital B. We add and subtract a and b. So a plus b gives 2p plus x is equal to a plus under root a square plus 2x minus y whole square. And when we subtract, it gives Now we subtract a and b. So we get 2q plus y. P terms, p plus x cancels out, is equal to a minus under root a square plus 2x minus y whole square. So from a plus b we can find p, and from this a minus b we can find q. So this is minus x plus a upon root 2, a upon 2 plus 1 by 2 under root a square plus 2x minus y whole square. And for q we get y plus a by 2 minus 1 by 2 under root a square plus 2x minus y whole square. So now we got p and q, we put it in dz, which is p dx plus q dy. So dz is equal to minus, we take terms like this, here also minus, so minus x dx minus dy. So this is plus y dy, minus we have taken common, a by 2 plus a by 2 dx plus a by 2 dy. So we can take common, and from here we take common, the terms are same, only sign is different. So 1 by 2 under root a square plus 2x minus y whole square into dx minus dy. So we can integrate, but before that we have to simplify the terms. So this is minus x dx plus y dy plus a by 2 dx plus dy, plus we put here, we do 1 x minus y is equal to t. So d of x minus y is dx minus dy, this is equal to dt. So this is 1 by 2 under root a square plus 2t square into dt. But what we do, we make this 2 as root 2, and root 2 we take inside, so root 2 and which is 2 and 2. So this 2 cancels out, and now this is the form. This is basically now 1 upon root 2 under root a square upon 2 plus t square dt. So this is integral of a square plus x square dx to the power half. A is equal to a by 2 and a by root 2, and x is equal to t. So now we apply the formula. This integral a square plus x square to the power half dx is x by 2 under root a square plus x square plus a square by 2 log x plus under root a square plus x square, or a square plus x square to the power half, and get the integration. So integrating, we get z is equal to, as I have said, we can remember this is equal to x square plus y square by 2. This is x plus y. Now 1 by root 2 we put outside, and then x by 2, x is here t, so t by 2 under root a square, so a by root 2 has, that becomes a square by 2 plus t square plus a square by 2, that is a square by 2 into 2, that is 4 log x is t plus, then here a square is a square by 2 plus t square double and this is half under root plus constant. So this can be written minus x square plus y square by 2. We put value of t is equal to x minus y, so plus a by 2 x plus y plus 1 upon root 2. This 2 we can take common, so 2 root 2 and x minus y under root a square by 2 plus x minus y whole square plus a square by 2 log x minus y plus under root a square by 2 plus x minus y whole square plus b. So this is the required answer. This example is of 1992 CSC. Here we have to find out complete integral of Px plus Qy is equal to Z1 plus PQ to the power half, which is xyz PQ, which is 0. So we bring z term on left side and this is equal to 0. So Charpit'S auxiliary equations are dp upon fx plus pfz is equal to dq upon fy plus qfz is equal to dz upon minus pfp minus qfq is equal to dx upon minus fp is equal to dy upon minus fq. We calculate the values of fx, fy, fz, etc. So fx is equal to p, fy is equal to q, fz is 1 plus pq to the power half with minus sign, fp is x minus 1 by 2 z 1 plus pq to the power half into q. And fq is y minus 1 by 2 z 1 plus pq to the power half minus half into p. So what we do, we take dp upon fx is p minus p 1 plus pq to the power half is equal to dq upon q minus q 1 plus pq to the power half. We need not to write further because from here we take common p 1 minus 1 plus pq to the power half is equal to dq upon q 1 minus 1 plus pq to the power half. These two will cancel out. So dp upon p is equal to dq upon q. Easily we can integrate them. So we had to take two fractions which are easily available. So integrating log p is equal to log q plus log a, p is equal to aq. So from the expression f px plus q is, this is aq plus qy minus z 1 plus aq square to the power half is equal to 0. So we take q common from here, ax plus y minus z 1 plus aq square to the power half is equal. So we square it, q square ax plus y whole square is equal to z square 1 plus aq square. We collect the terms of q square and this gives q square ax plus y whole square, and from here is equal to z square. Now we get q in the form of z etc. Q is equal to z upon, after taking square root, ax plus y minus az square to the power half. And p is equal to aq, so we put the value of q into it. This is az upon ax plus y square minus az square to the power half. Now we put value of p and q in z, p dx plus q dy. So this comes dz is equal to az upon ax plus y whole square minus az square to the power half dx plus z upon ax plus y whole square minus az square to the power half dy. So instead of writing this, we can write dz is equal to, because denominator is same, so z dx plus dy, az dx plus z dy upon, denominator is same, ax plus y whole square minus az square to the power half. Now in this we assume that ax plus y is equal to because here is also a there, we assume under root a u. So we get dx a into dx plus dy is equal to under root a du. We can write dz, in this we take common z, a dx plus dy, this we have now, a dx plus dy upon ax plus y whole square minus az square to the power half, which is equal to z under root a du upon, this value is under root a u whole square minus az square to the power half. So what happens now, this also becomes a, so we can take a common, under root a common, so z under root a du upon under root a, this is a, so square, so we take this common, and to the power half is also there, so this becomes again under root a, so this cancels out, u square minus z square to the power half is equal to dz. We bring z here is equal to du upon u square minus z square to the power half. From here we calculate du upon dz, and du upon dz is u square minus z square to the power half upon z. Now we simplify it, it becomes u upon z square, means we are dividing by z. minus z square upon z whole square to the power half. So this is u square upon z square minus z square upon z square. So what we did, we made it as z square to the power half denominator. So what happened, u upon z whole square minus z square, so this becomes u upon z whole square minus 1 to the power half is equal to du upon dz. And this is a homogeneous linear equation, homogeneous linear equation. So now what we do, we put u upon z as v. So this gives u is equal to zv. So du is equal to v dz. V dz plus z dv upon dz, z dv upon dz. So we take du upon dz is equal to v plus z dv. So this becomes z dv, and du upon dz is equal to v plus z dv upon dz. This value, and we get v plus z dv upon dz is equal to u upon z square minus 1 to the power half, which is equal to v. So this is v square minus 1 to the power half. Now we separate the terms. So this becomes dz upon z is equal to dv upon v square minus 1 to the power half minus v. Now we can multiply it by v square minus 1 to the power half plus v in denominator as well as numerator. So what happens, this becomes v dv upon v square minus 1 to the power half plus v square minus 1 minus v square. So this will cancel out, minus 1. So this is minus v square minus 1 to the power half plus v into dv is equal to dz upon z. Use this formula, x square minus a square to the power half dx integral. X is v here, this is x square minus 1 square, and this is separate because we can separate it. Integral minus is outside, v square minus 1 dv to the power half plus dv plus v dv. So this is minus v upon 2 and v square minus 1 to the power half minus 1 by 2 log v plus v square minus 1 to the power half. This is for first part, this part, and this is minus v square by 2 plus b. So this is the required answer where v is equal to u upon z, which is equal to ax plus y upon z under root a.